Okay, this is lesson 9.1, which is adding and subtracting polynomials. And in today's lesson, you should get two things out of this. The first one is that you should be able to describe polynomials. We're going to have a lot of new terms we're going to talk about, and you need to know how to describe them. The second thing is that you're going to learn how to add and subtract them. So first, we're going to tackle this how do we describe a polynomial? What is a polynomial? So the first thing we're going to start with is what's a monomial. So a monomial is an expression that is a number, a variable, or a product of number and variables. So down here, these are all examples of monomials. 5 is a monomial because it's a number. 7 is a number because it's a monomial. X is a monomial because it's a variable. 5x is a monomial because it's a product of a number and variables. And so is 7xy because it's a product of a number and variables. That's a monomial. So what's a polynomial? Well, a polynomial is an expression that's the sum or difference of two or more monomials. So if I take these monomials and if I add them, sum, or subtract them, difference, I've just made a polynomial. So for instance, 3x plus 4y, that's a polynomial. Or like how I tab these terms up here, if I do 5 plus x minus 7xy, that's a polynomial because it's the difference of two or more monomials. So notice how this says a difference of two or more. So let's look at a binomial. So we know bi means two. A binomial would contain just two terms, like 3x plus 4y. That's a binomial. Whereas a trinomial, tri means three, contains three terms. So like 3x plus 4y plus 7, that's a trinomial. Or x squared plus 6x plus 8. That's a trinomial. 1, 2, 3 terms. 1, 2, 3 terms, trinomial. So let's look at, and if it's more than 3, so like this was a binomial is 2, a trinomial is 3. If it's more than 3, then we just say it's a polynomial. A trinomial, binomial is a type of polynomial, but they're just specifics. If it's 2 terms, binomial, 3 terms, trinomial, 1 term, monomial. So let's look at this now. Degrees of polynomials. So a degree of a polynomial, this is another term we're going to be talking about here when we describe polynomials. A degree of a polynomial is the greatest exponent of the monomials. So like when I look right here, this would be considered the first degree because it's 2x plus 7. My greatest exponent here, you can't see it, but they don't write it because they don't have to, but this is really a 1. So it's a first degree. And if you think about it, 2x plus 7, that's linear. So we would say that that is a linear binomial. Okay, second degree would mean that the highest exponent is a 2. So like this example right here, x squared plus 6x plus 8. My highest exponent is a 2, so it's a second degree. If it's a second degree, then it's quadratic because this is a quadratic equation. So I would actually call this right here, I would say it's a quadratic trinomial because it has 1, 2, 3 terms. So again, this one up here, 2x plus 7, this is a linear binomial because it has 2 terms. This one right here has 3 terms, 1, 2, 3. Its highest degree is 2, so I would call it a quadratic trinomial because it has 3 terms. Now, if the highest exponent is to the third degree, the highest exponent is a 3, we call that cubic. So this right here would be cubic because my highest exponent is a 3. I also have an exponent that is 1 here, but I don't care about that because I just want the highest one, which is a 3. And actually, I would name this a cubic binomial because there's 2 terms. So again, if it goes higher than third degree, it doesn't have special names. We just keep it, we would say it's a 4th degree or a 5th degree or a 6th degree. But if it's a first, second, or third, first degree, call it linear. Second degree, call it quadratic. Third degree, call it cubic. Okay, so let's look down here. Other examples. So this one I have x to the 5th plus 7x minus 2. This one I would call a 5th degree because my highest exponent is a 5. Down here I have 6x squared plus 7 minus 9x to the 4th. Some people might say, oh, well, this one, the highest degree is 2, it's quadratic, but it's not. Because even though it comes at the end, my highest exponent actually here is the 4, so this is a 4th degree trinomial because I have 3 terms. 1, 2, 3. Okay, so, oh, let me move that right here. So what I want you to do right now, and I don't know, you might already seen it, but I want you to try Quick Check 2, which is on page 495. It says, write each polynomial in standard form. Now, what does standard form mean? Standard form means you need to write it from the highest exponent to the lowest exponent. So this right here, these are all in standard form because my highest exponent is the x squared, then the x. X to the third, this would be x to the first. This is in standard form also. This one right here is not in standard form. So if I was going to rewrite this one and put it in standard form, I would want to rewrite it as highest exponent first, so negative 9x to the 4th. My next highest exponent is the 6x squared, so plus 6x squared plus 7. Okay, so again, do Quick Check 2, A, B, and C. Pause the video, hit play when you're ready. Okay, here's what you should have had for your answers. So we actually did this first one together. So this negative 9x to the 4th plus 6x squared plus 7, that's a 4th degree trinomial because you were supposed to name it also. This next one, you should have had negative y to the 3rd because that's the highest exponent plus 3y minus 4. Highest degree here is a 3, so you'd call it a cubic trinomial because there's 3 terms. This one down here, this one you can simplify because 7v minus 11v is negative 4v. So this is negative 4v plus 8. So my highest degree is a 1 here, so that's a linear binomial because there's 2 terms. Now something else we need to talk about, because these are all polynomials, but we learned first about monomials. So a monomial, again, is if it's a product, it can be just a number, a variable, or a product of number and variables. But to find a degree of a monomial, that's a little different. So I've got some examples here. So when you look here, you might say, after what we just talked about, oh, my highest degree here is a 5. But it's not, because it's not a polynomial. This is a monomial. And when it's a monomial to find the degree, you actually add the exponents. And I understand we just got done with exponential relationships, and we talked about you only add if they have the same base, but this is different. If it's a monomial and they want to know the degree, you add the exponents even if the bases aren't the same. So 4 plus 5 is 9. Here, this would have a degree of 4 because this is really x to the first. They just, again, don't write the 1 there. 1 plus 3 is 4. So that's degrees of monomials, and that's a very big distinction that you need to make between monomials and polynomials. Okay, so that was the first part of this lesson, which was how to describe polynomials. So now we're going to look at how do we add and subtract polynomials. And the big thing here is we want to look for like terms. So first I'm going to start with just adding them. So I'm looking for like terms, and we want to group them together. So I'm going to underline 6x squared, x squared. I'm going to match that up with my other x squared, which is 2x squared. So 6x squared plus 2x squared, that is 8x squared. Now I'm going to look at just my x's, so my variables that have a degree of 1. And I'm going to put squigglies underneath those so I remember and can classify them that way. So positive 3x minus 6x ends up being minus 3x. Be careful of those negatives. And then I just have some numbers left over. So plus 7 minus 4 is plus 3. And that's how we add them. So go ahead and try Quick Check 3. There's 4 problems there. Go ahead and pause the video and do all 4, and then hit play when you're ready. Okay, so A, we had 12m squared plus 4 plus 8m squared plus 5. So again, I'm going to go ahead and look at, okay, here are my degrees. The second degree, so I'm going to go ahead and say 12m squared plus 8m squared, so that's going to be 20m squared. And then just my numbers, plus 4 plus 5, that's plus 9. So 20m squared plus 9. For B, let me flip this over so we have some room here. On here, B, that one was t squared minus 6 plus 3t squared plus 11. So I've got t squared and 3t squared. This is 1t squared. Again, the 1 just doesn't show up, so that's 4t squared. And then I've got minus 6 plus 11 is going to end up being plus 5. For C, we have 9w to the third plus 8w squared plus 7w to the third plus 4. So I've got my third degrees. 9w to the third plus 7w to the third is going to be 16w to the third. I've just got this one right here, my second degree, which is plus 8w squared. And then over here I've got plus 4, so it's just plus 4. And again, notice I'm writing these in standard form because it's the highest exponent to the lowest. And then on D, we have 2p to the third plus 6p squared plus 10p plus 9p to the third plus 11p squared plus 3p. So I'm going to do squigglies under the p to the third. So that's 11p to the third. I'll do flat lines under the p squared. So that's 6p squared and 11p squared is 17p squared. And then I'll circle my first degrees, 10p and 3p, 13p. And that's it. So that's how we add polynomials, but the last part that we have to do is how do we subtract polynomials. So subtracting polynomials is more difficult because what you have to remember is I have my first polynomial here, which just take a look at this and think, oh, what would this polynomial be called? This would be a cubic trinomial, and this one is also a cubic trinomial. So it's cubic because it's a third degree, and there's 3 terms, so it's a trinomial. Okay, so since this is minus, this subtraction, you're not just subtracting the 5x to the third, you're subtracting everything. So that subtraction goes to everything. So you want to distribute that subtraction sign. So I'm going to rewrite this as 2x to the third plus 4x squared minus 6. And I'm going to actually rewrite this as an addition problem. So I'm going to make this plus a negative and distribute that negative. So now I have plus negative 5x to the third minus 2x plus 2. Why did it become plus 2? Because a negative and a negative makes a positive. So now that I've distributed that negative and I made it an addition, this is a much easier problem to tackle. So I have 2x to the third, negative 5x to the third. So that's negative 3x to the third. I have 4x squared minus 2x squared, so that's positive 2x squared. Ooh, that wasn't a squared there. Never mind. I can't subtract those because those are not the same. Let me erase that. Thought that was a squared there, and it's not. So this is just, that's my only like term is 4x squared, so I just write 4x squared. Now I come over here. This is a completely different term. I'll circle that. So it's minus 2x. And then I have my regular numbers left, and I've kind of run out. I guess I'll box it. So negative 6 plus 2 is minus 4. So that's what we should have had there. And you would call this a cubic 4-term polynomial. So now go ahead and pause the video and do quick check 4. There's 3 problems there, and then we'll check them. They're all subtraction. Okay, so let's go ahead and do the first one. A, we have v to the third plus 6v squared minus v minus 9v to the third minus 7v squared plus 3v. So again, what I'm going to do is I'm going to turn this into plus and negative and distribute that negative to everything. So this becomes v to the third plus 6v squared minus v. Plus, now that's going to be a negative 9v to the third. It's going to become a positive 7v squared, and it's minus 3v. So now I look for like terms. Here's my v to the thirds. So this is 1v to the third minus 9v to the third is negative 8v to the third. V squareds. 6v squared and 7v squared is going to end up being positive 13v squared. And then I've got, this is a negative 1v and a negative 3v, so that's negative 4v. Now when I do b here, I'm going to start off by rewriting it the way we should. So for b, the first one stays the same, the first polynomial, 30d to the third minus 29d squared minus 3d. But now I'm going to change that to plus plus, and then it's going to become negative 2d to the third minus d squared. So I look for my like terms. 30d to the third and negative 2d to the third are the same, so that's 28d to the third. I have negative 29d squared, and that's a negative 1d squared, so that's negative 30d squared. And then that negative 3d is by itself. It's just hanging out. Okay, last one. So again, first polynomial stays the same. Second one, I'm going to change it to plus a negative. So when I make that a plus, I need to distribute that negative. So negative 6x squared minus x minus 8. Okay, so I have 4x squared minus 6x squared is negative 2x squared. I've got 5x and negative 1x, so that's positive 4x. And plus 1 minus 8 is minus 7. Okay, that is it for this lesson. If you need to go back and watch anything, go ahead. And that's it.